Hello, dear students. Welcome to the first chemistry session in Chapter 4, Chemical Reactions. At the end of this video, you will be able to distinguish between physical and chemical change, list the signs of chemical reactions, write chemical equations corresponding to some reactions, state the law of conservation of matter, Lavoisier's law. You need in this session a pen and your chemistry booklet. Consider the following two transformations: melting of an ice cube and rusting of an iron nail. What's the difference between these two transformations? In ice, the water molecules have a special arrangement in the solid state. However, in water, the water molecules have another arrangement in the liquid state. So this is a physical transformation. A physical transformation doesn't change the nature, identity, and composition of the substance. However, in the rusted iron nail, iron is made up of iron atoms. Iron reacts with oxygen in the presence of air moisture to form a new compound called iron oxide, which is rust. So rust is made up of two elements, iron and oxygen. So this is a chemical transformation. A chemical transformation changes the nature, composition, and the properties of the initial substances. Let's take more examples having physical transformation. Tearing of a paper, breaking of a glass bottle, slicing a cake, deforming a can, cutting a log, pouring milk. Other examples having chemical transformation: burning of wood, combustion of butane gas, photosynthesis, removing an oily spot by detergent, frying an egg, using bleaches for toilets. Chemical reactions are constantly occurring in our everyday life. But what are the signs that indicate that a chemical reaction takes place? A chemical reaction can be detected following some signs. For example, change of color, gas release, formation of precipitate, exchange of energy by release of heat to the surrounding, exothermic reactions, or by absorption of heat from the surrounding, endothermic reactions. How to represent a chemical reaction? By an equation. A chemical reaction is represented by an equation where reactants and products are shown by their symbols and formulas and separated by an arrow, where reactants are placed to the left and the products to the right. Also, the physical state of each chemical substance is represented by a letter in parentheses on the right of each symbol and formula: S if it is solid, L if it is liquid, G if it is gas, and AQ if it is an ion in aqueous solution. Let's take two examples. Carbon reacts with oxygen to produce carbon dioxide. Carbon and oxygen are the reactants, where carbon dioxide is the product. So the chemical equation is C plus O2 gives CO2. Iron sulfide is formed from the reaction of iron and sulfur. Iron and sulfur are the reactants. However, iron sulfide is the product. So the chemical equation is Fe plus S gives FeS. Ammonia molecule NH3 is made up of one nitrogen atom and three hydrogen atoms. Ammonia is formed from the reaction of nitrogen N2 and hydrogen H2. Can this reaction be completed if we use one molecule of nitrogen and one molecule of hydrogen? Sure, no. How many H2 molecules are needed to react with 1 and 2 molecule to produce ammonia molecules? 3 H2 molecules. One nitrogen molecule reacts with 3 hydrogen molecules to produce 2 ammonia molecules. These are the reactants, and the 2 ammonia molecules are the products. In the reactants, we have 2 nitrogen atoms and 6 hydrogen atoms. Also in the products, we have 2 nitrogen atoms and 6 hydrogen atoms. So, in the course of a chemical reaction, the atoms of the different species involved are conserved. The elements involved are also conserved. In a balance, 1 mole of N2 and 3 moles of H2 are in equilibrium with 2 moles of NH3. The mass of the reactants is 34.080 grams. Also, the mass of the products is 34.080 grams. This is the law of conservation of matter, which is called Lavoisier's law, which states that during a chemical reaction, the mass of the products formed is equal to the mass of the reactants consumed. Note that modern physics has demonstrated heat evolution in a chemical reaction always occurs with a small mass loss. A very small quantity of matter is transformed into energy. Therefore, according to Lavoisier's law, a chemical equation must be always balanced. But how to write a balanced chemical equation? Consider the following equation. Count the number of nitrogen and hydrogen atoms on both sides of the equation. In the reactants, we have 2 nitrogen and 2 hydrogen atoms. In the products, we have 1 nitrogen and 3 hydrogen atoms. Put a coefficient in front of the chemical formula so that the number of each type of atoms is the same on both sides of the equation. The number of atoms of each type is counted by multiplying the coefficient by the subscript. Multiply H2 by 3 to obtain 2 nitrogen atoms and 6 hydrogen atoms in the reactants. Multiply NH3 by 2 to obtain 2 nitrogen atoms and 6 hydrogen atoms in the products. Note that the coefficients added must be natural numbers, since in nature there are no parts of matter. This is the balanced chemical equation. To write a chemical equation, consider the following notes. Metallic elements are monoatomic and solids. Example Fe, Al, Ag, Cu, except mercury, Hg, which is liquid. Molecular elements are gases. Example H2, N2, O2, Cl2, except Br2, which is liquid, and I2, which is solid. All compounds containing the ions Na+, K+, Li+, NH4+, NO3-, ClO3- are always soluble. All compounds containing the anion SO4 2- are soluble unless they are bonded with the cations Ba2+ and Ca2+. All compounds containing the anions Cl-, I-, and Br- are soluble unless they are bonded with the cations Ag+ and Pb2+. All compounds containing the following anions O2-, S2-, OH-, PO4 3-, CO3 2- are always insoluble unless they are bonded with the cations Na+, K+, Li+, and NH4+. Dear students, you have to study worksheets 12 and 13. Thanks for listening.